पोटेंशियल का बारे में कुछ और खास बात है. Potential is a scalar quantity. Potential depends on reference frame. That means you can choose any point in a region, in a space, to be having zero potential. But preferably, we consider potential at infinity, at infinite distance, to be zero. And we measure potentials of other points. And for that reason, potential will become infinite at the origin. So these may appear as short questions, MCQs. Anyway, let us start the theories. First theory is that, try to understand this, potential of point charge, potential of a dipole, those are the main basic theories. Then we will be doing potential of a sphere like we did for electric fields. So potential due to a point charge we will be doing. Suppose this is a point charge, Q, or let us take it capital Q. This is infinite distance. We have selected a unique positive charge. So its charge Q equals to +1. We are bringing that charge in this direction. So that is having a displacement in this direction. Now, this is also positive charge. This is also positive charge. So this will repel that charge by a force when it comes to this position, any position, suppose A, then it would be repelling it by a force given by F equals to K, Q, its Q is 1, so I'm writing 1 here, into Q, that is Q. So Q1, Q2 divided by X square. X is its distance of the distance of point A from capital Q. We may consider this to be origin. Now, so at a distance x, force is this much. If we have to, this charge is again +1, this charge. Now if we move it a further distance by dx, very small tends to 0. Then work done given by f dx. Work done equals to force into displacement. But there was a cos theta, and that theta is 180 degrees. See this? This charge plus, this unit positive charge is also plus. So this will apply a repulsive force in this direction. So the direction of force is along positive x-axis, but the displacement is along negative. So the angle between these two is 180 degree. So cos 180 degrees. So it will become negative of f dx. So it will become negative of f is this much. So k q by x square into dx. That is dw. So total work done w would be given by integration dw equals to integration of minus k q dx by x square with limits. We have started bringing the charge from infinity, and finally we are bringing the charge to this point, somewhere over here. Suppose this point is P at a distance small r from origin or capital Q. So its limit would be infinity to r. Now you have done so many cases like this in class 11 in gravitation chapter. So it is easy. So W minus 1 by infinity. That means k q by r. That is the work done. Now, from definition we had done that potential is nothing but this work done to bring unit positive charge. So potential is also k q by r. One thing I should remind you, that if this charge is positive, then it is plus kq by r. Plus, if this charge is negative, then it would be minus kq by r. So we can say formula of potential is k plus minus q by r. Whatever the charge q possesses, put that sign. Understand this meaning. K means 1 by 4 pi epsilon naught, Q by R. Q positive, negative. You have understood this. So the graph of V versus R would be like this. I had told you inversely proportional rectangular hyperbola. So it would be something like this. But if charge is negative, V will also be negative. So in that case, the graph would be like this. V would be negative. That's it.